A woodworker makes round two-tone tabletops out of a maple wood that costs $4.19 per square foot and black walnut wood that costs $5.31 per square foot. Write functions using x, the radius of the inner circle measured in feet, for m of x to represent the cost of maple for a tabletop, w of x to represent the cost of black walnut for a tabletop, and w minus m of x to represent how much more per tabletop the woodworker must budget for black walnut than maple. If a customer orders a 24-inch diameter two-tone tabletop, how much more will the woodworker need to spend on the black walnut than the maple for the customer's tabletop? Okay, so we're trying to figure out the functions for the black walnut, the cost of the black walnut on this tabletop, and the cost of the maple, and then we'll subtract the maple from the black walnut to get the additional cost for just the maple part of the tabletop. So let's go ahead and start with, m of x here, which is the cost of the maple. And so we know the cost of the maple wood, it tells us up here, is, let's see, $4.19 per square foot. So we know it's going to be $4.19 times however many square feet. And remember that square feet that's area. And so for the maple area, that's a circle, and our area for a circle is pi r squared. And in this case, x is our radius. And so we can just write, well, that's going to be $4.19 times the area, which is pi x squared. And we don't actually need parentheses around this since they're all multiplied, so we can just write 4 and 1900ths pi x squared. And then for the walnut, we know that's going to be w of x. And w of x, it tells us is the walnut is $5.31. So we know it's going to be $5.31 times whatever the area is. And then notice the black walnut one's a little bit trickier because it's a ring. It's not the entire circle. So it's basically the big circle, but then we need to somehow get rid of this small part. Well, we can just subtract out the area of the maple part. And so basically it'll be the area of the big circle minus the area of the smaller circle, and that will give us just the walnut part. So to get the area of the big part, so I'll just write here, this will be the big circle, then that's going to be, again, pi r squared, but in this case, the radius is going to be not just 1x, but if you see here, it's also the x for the walnut part. So it's going to, starting in the middle, the big circle will be the whole x part there. So it's going to be x plus x, which will be 2x squared. And then we need to still subtract out the smaller one. And we just found the area of the smaller one in our last equation, which was pi x squared. So that was the small circle. And so just simplifying this out so it looks a little bit prettier, we have 5 and 3100ths. And then 2x squared here can be simplified to 2 squared is 4x squared. And I'm just going to put that 4 in front. So we have 4 pi x squared and then minus pi x squared. So we have 5 and 3100ths times, well, 4 pi x squared minus pi x squared. They both have pi x squared in common, so we can just subtract the coefficients. So 4 minus 1 is 3, so we have 3 pi x squared. And then 5 and 3100ths times 3, we're just going to get 15 and 9300ths pi x squared. Okay, so now we can go ahead and find the other part they asked us, which is w minus m of x. So basically that is just the same thing as w of x minus m of x, because we want to find the additional cost of this walnut. So what we can do is we can just plug in w of x and subtract m of x. So I'm actually going to move the equation over a tiny bit this way so I have more room. So w of x will be 15 and 9300ths pi x squared, and then m of x is going to be 4 and 1900ths pi x squared. So notice that again, they both share a pi x squared, and so we can just subtract the coefficients on those. So 15 and 9300ths minus 4 and 1900ths is 11 and 7400ths. And we still have the pi x squared. Okay, so now let's go ahead and answer their question about the customer who orders a 24-inch diameter two-tone tabletop. So 24-inch diameter, to go ahead and find in our equation, I'm just going to go ahead and copy down the w minus m of x equation. Okay, so the 24-inch diameter, we need to be able to put that somewhere in our equation. And we know that x is the radius of the inner circle measured in feet. So first of all, we know that 24 inches is the same as 2 feet. And so that puts that into feet for us. And now we need it in terms of what x is, or this inner diameter. And so we know, well, 24 inches is the whole diameter. And on our table, then that the diameter is actually 1x, 2x, and then the other side 3x, 4x, since there's 4x's there. So that is just, we know that 4x is our diameter of the table, and we know that the customer was 24-inch diameter, which is 2 feet. So we know that equals 2 feet. And so to actually solve and find out what x is in our equation, then we just would have to divide by 4 on each side. And so that would be x equals 2/4, which is just 1/2 feet. And so that gives us the inner radius, which now we can go ahead and plug that into our equation. And so plugging that in, then we get 11 74/100 times pi times 1/2 squared. And typing that in the calculator, that gives us approximately 9 220 thousandths. So rounding that off, it's going to be dollar amount. So we can say that the customer will end up paying about $9.22 more for walnut than maple. And so let's go ahead and summarize our answer. M of x equals 4 1900ths times pi x squared equals 4 1900ths pi x squared. W of x equals 5 3100ths pi 4 pi x squared minus pi x squared equals 15 9300ths pi x squared. W minus m of x equals 15 9300ths times pi x squared minus 4 1900ths pi x squared equals 11 7400ths pi x squared. The diameter of the woodworker's two-tone tabletop is 4x feet. The customer orders a 24-inch or 2-foot diameter table. 4x equals 2, so x equals 1/2. W minus m of 1/2 equals 11 7400ths times pi times a half squared equals 2 935 thousandths. Pi equals 9 221 thousandths. The woodworker will spend approximately $9.22 more for the black walnut than for the maple wood for the customer's 24-inch tabletop.